So I'm going to be demonstrating a MapReduce data mining job for some log files. So right here we've SSH'd, or we're using SCP, and we've connected to the Ubuntu server, which has our logs that we're interested in. So we're going to go ahead and copy these over, and I've already done this ahead of time, so I'm not going to do that. But copy these over. We're going to go ahead and open up the Hadoop command prompt. And we need to copy them into HDFS. So HDFS DFS dash copy from local, and that was in let's see Hadoop data slash action log dot log. In the destination we're interested in is input slash logs other slash. All right. Alright, it's confirmed. 621,000 bytes. This file, actionlog.log, is now in our distributed file system. So let's take a look at what it looks like. Alright, so right here we have an action, which is the URL that was accessed, an HTTP method, for example, post or get. We have a username, and then we have a file. And for certain actions, username and file will be NA, not applicable, because some requests don't have usernames or files associated with them. So let's open up the code. This is obviously JSON. This is written in C#, and it targets Windows Azure as the Hadoop environment. So we've created this class, a log record class, that has user, action, HTTP, and file, just like the log record we just looked at. And what's really nice about C# is when you use the C# Hadoop MapReduce client, they have this JSON in mapper base, where as long as your value, or as long as whatever is coming in from your input file has the same fields as the class that you pass into this JSON in mapper base right here. So for instance, user, action, HTTP, and file, it'll automatically parse those values from the JSON line that comes in and create a new log record object for you. So essentially what we're doing here is we're parsing the action, the user, and the value, and those are going to be keys, and we're emitting along with it 1, because right now what we're interested in doing is counting which URLs are we hitting the most, which users are the most active, and what HTTP methods are being accessed the most. And these this data in production could be very useful for something like caching, or for something like determining how we're going to spend our time improving, like which services we're going to prioritize improving and speeding up, which services are eating up most of our bandwidth so we can work on optimization. And down here the reducer is pretty simple. For each value in the enumerable values, we're going to parse the integer that comes with it and increment that counter, and then we're going to emit the key value. And then we have this driver over here. It's pretty simple, it just executes the job. So let's go ahead and run this. Alright. I'll pull up the job tracker as well. Okay, so the job has started. This is the job tracker. As you can see, this is a 1-node local cluster with 2 map task capacity and 2 reduced capacity. It's a 4-node machine with 16 gigabytes of RAM running at 3.5 gigahertz. And right now we have our job running. The map was successful. Obviously, this log file is only 8,000 lines, so the reduce ran pretty quickly, and the map as well. So let's go ahead and look. Now we'll copy our output slash logout slash part 000 to C Hadoop data. We'll go ahead and open that up in Notepad and take a look. Here we go. Okay, so as we can see here, Craig is by far the most active user with 8,500 requests. I believe he was caught in an infinite loop last night making some requests to the server, specifically requested to some get requests to list files and get file. And that's it. That's an example of our MapReduce program running to get some data mining statistics, and this would easily scale to process billions of records without problem.